So today we're going to start into chapter 11, which is all about area. We'll get into circles as well. We'll talk about sectors and arc lengths and things like that too. Today we're going to ease into it and just talk about some of the areas and how to find the areas, of some shapes that you already know how to find the area of. Which we're going to talk about triangles, rectangles, squares, and then parallelograms, which you probably have seen as well, just not as much as the other guys. Okay, so areas of triangles, parallelograms, squares, rectangles. Some quick definitions for you. In a parallelogram, each pair of parallel sides of a parallelogram are called bases. So these guys are bases, or these guys can be considered bases. Okay? The height of a parallelogram, and you're going to see why in a minute, why we're talking about bases and heights of parallelograms. But the height of a parallelogram is the shortest distance between bases of a p-gram. Now, what does that mean? It means that if you were standing here on this base, the shortest distance to the next base would be a distance right at it, right? That would be shorter than going out to here or something like that. So in other words, right at it means at a perpendicular. So we want the height to be that perpendicular distance between the two bases. All right? So for those two bases, it would be there. For these two bases, it would probably be something that sort of travels outside of the parallelogram, and we'll see that at some point. Okay? So now that we know that, let's talk about some area formulas. First, the area of a square. A square is like a rectangle where the area is base times height. But the base and the height in a square are exactly the same. Because all the sides are the same, right? So the area formula for a square basically reduces down to side squared. Okay? The next postulate that we're going to talk about is the fact that if two polygons are congruent, then their areas are going to be the same, and I think that just makes a ton of sense. So not a lot that we need to worry about there. Okay? This next postulate lets us know that if you want to find the area of an irregular shape or the area of a shape that you don't have a formula for, you can always break it down into parts that you can find the area of, and then add those different area parts up. Okay? So the area of a region is the sum of the areas of its non-overlapping parts. That's something that I've used before when trying to figure out how much mulch I have in my mulch beds, to try to figure out how much mulch I need to order. Mulch beds, landscape beds are very irregular in shape, and so you just kind of cut it up into some different shapes that you can find the area of, and go from there, and then add all those up. Okay? Some more theorems for you, and it's the area of a rectangle, parallelogram, and triangle. Area of a rectangle you already know. I know you're thinking length times width, but now we're going to consider it in terms of base times height sometimes as well, simply because base and height is going to keep coming up in other shapes as well. Now, since a parallelogram is nothing more than a slanted rectangle, you don't lose any area when you slant a rectangle, so the area formula is just the same, base times height. And the area of a triangle is going to be 1/2 base times height. Again, these are formulas that you've seen before. Okay, so let's start to use them. Over here, this is a parallelogram, PQRS, and we want to find the area of it. Okay, two different ways you can approach this. Number one, the first method here, if you want to look at it that way. Okay, is to consider this as a base, this as a base, and 4 is the distance between them, because it's a perpendicular segment there. Which makes this easy enough. We just take the length of the base times the height, and we get 48 square units. Okay? Or, if you want, you can look at this as the base. So a second method here, a second way of looking at this is to look at 6 as a base. Now, if you look at 6 as a base, then the other base is up here, and the distance between them is represented by this segment, which is 8. So 6 times 8, which is also 48 units squared. Okay, so you get the same result, just make sure you pay attention to what you are considering your bases and then that distance between them. All right? Now, find the perimeter and the area. Now remember that perimeter is just you're adding up all the sides, right? Perimeter, easy enough. This is a parallelogram, so the opposite sides are congruent. So this is 20, this is 30. So to find the perimeter, just add up all the sides. 20 plus 20 plus 30 plus 30, which is 100 units. The area is base times height, where the base could be this 30, and the height would be this 17. So it would be 510 units squared. Okay? Just be sure not to use this slanted segment as the height. We don't do slant heights. Not right now. Okay? All right? How about the perimeter and area of this? Give it a shot. Stop the video and start it back up and see if you get it right. Did you get this? Perimeter, just add up all three sides, 17, 10, and 21, and you get 48. Area is 1/2 base times height, where this is the base, and this is the height of this triangle, just how tall it is, right? And we want to use that at a perpendicular because that's how we measure height. It's a perpendicular height, okay? All right, try again. Now another example here for you where we're going to work backwards, where we know the area is 36 square inches, and we want to find the length of the base and the height of the triangle, and where we know that the base is twice the height. Now we don't know this is a right triangle, but we can draw it in, sort of like a right triangle, where the height is at this perpendicular. And if this is the base, which it would be, because the height needs to be perpendicular to the base, then we know that the height, or that the base is twice the height. So let h be the height, and that means the base would have to be 2h. We find the area by going 1/2 base times height. Well, now the base is 2h, and the height is just h. So half of 2h is h. We get h times h, which is h squared. Now we know the area already is 36. So 36 is going to be equal to h squared. You square root both sides, and h is 6. If the height is 6, that means the base has to be 2 times 6, or 12. And these are in inches. Okay? Just working backwards. Another use for this, and we're going to use that theorem or the postulate, whichever one it was. I talked about that if you the area of a region is just the sum of its area parts. So if you're going to paint this barn, this face of the barn is a pentagon, right? It's 5 sides. We know the gallon of paint covers 350 square feet. How many gallons are you going to need? Which would be useful when you go to the paint store to buy paint. Well, we don't know how to find the area of a pentagon. So what we can do is we can break this up, and you can see that it's already been done, into a triangle and a rectangle. Right? So, first things first, we need to find the area of the rectangle. Which is just going to be 18 times 26. Okay. which is some quick calculating here, 468 square feet. Now we need the area of that triangle. Okay, well here's what we know. It's a right triangle where these two sides are the same, so it's an isosceles right triangle, which means that this is a 45, which means that this is a 45, 45, 90 triangle. So whether you use special right triangles or if you use Pythagorean theorem, because these sides are going to be the same, x squared plus x squared equals 26 squared would be one way you could do this. You could go x squared plus x squared equals 26 squared to find x. Or you can use the specials, where the hypotenuse is always radical 2 times a leg, where the hypotenuse is 26 and the leg is, say, x. Either way, you should get 13 radical 2 for the for each leg, here and here. And the reason why we want that is because remember that the height needs to be perpendicular to the base. So one of the legs can be the base where the other leg can be the height. So in other words, the base and the height are both going to be 13 radical 2. So you go 1/2 times 13 radical 2 times 13 radical 2. And I'm going to go ahead and multiply the base and the height out first. 13 times 13 is 169. Radical 2 times radical 2 is the square root of 4. The square root of 4 is 2. Well, if I multiply 169 by 2 and then cut it in half, then we're going to get right back to 169 square feet. So the total square footage is this 468 plus 169, which is 637. Now, since a gallon of paint covers 350 square feet, I've got to divide this by 350 to find out how many gallons I'm going to need. So I'm going to need 1.82 gallons, which you really can't buy 0.82 gallons, so you're going to need 2. You need 2 gallons. And that should cover the side of that building. Okay? Now, last but not least, I want to show you one more thing so you can get to your homework and be able to do it pretty well. A robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes. About how long does it take for it to clean a carpet covering a room with the dimensions to the right? Now, we can certainly cut this up into 2 regions and then add those two, the rectangle and what would be basically a square. But I'm going to approach it a different way, because we could also look at this as one giant square with a piece cut out. So not only can we add up pieces, but we can actually subtract out parts that we don't need. Okay? So what does that mean? That means that I'm going to find the area of this giant square first, which is going to be 9 times 9, or 81 square meters. And then I'm going to find the area of the missing part, so area of M, which is going to be this right here, which is 5 on this side. And then because this is all 9, and we're going to subtract out 5, this is going to be 4. So we got to do 5 times 4, which is 20 square meters. Which means that the total area is just going to be 81 minus 20, which is 61 square meters. Now, if the robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes, that means I've got to find out how many square meters, or how many 8 minutes I need, right? I'm going to divide the 61 by 2, right? Or just set up a proportion would be easier, right? We know that the robot can clean 2 square meters in 8 minutes. We have 61 square meters. So now just cross multiply this, and you get 2x equals 488 divide by 2, and this is going to take 244 minutes. Okay, so quite a while. Okay, all right. So there you go. Not only can you cut things up into different shapes that you can find the area of and then add them together, but you can also subtract some areas out if you don't need a part. All right, there you go. Homework's out in Canvas. Make sure you get that done next time.